Okay, so for this particular example, we're going to be covering how to factor out the greatest common factor when given a polynomial. So here we have this trinomial, and we need to factor out the greatest common factor. So in order to do so, that means that we need to know, well, what is the greatest common factor? All right, so that's what we need to do first. That's what we need to find. So finding the greatest common factor, we need to start off by comparing our numbers. And then in a little bit, we'll be comparing our letters. So looking at our numbers, 22, 36, and 12. Now remember, it's always best to start with your smallest number because your common factor has to be within that smallest number. And looking at a 12, the only factors of 12 are 1 and 12, 2 and 6, and a 3 and a 4. So we need to figure out which one of those numbers, or which is the biggest one that would go into 22 and a 36. 12 doesn't go into 22. 6 doesn't go into 22. 4 does not go into 22. Neither does 3. Now 2 goes into 22 and it also goes into 36. So our greatest common factor as far as our numbers are concerned is a 2 for this problem. Then we need to look at our variables. So first off, we do need to make sure that each one of our terms does have the same variable, and we can see here that we do have an x in each one of our terms. Now what we're looking for is the lowest power on that x. So remember, when it comes to the variables and finding the greatest common factor, that as long as each term has that variable, we want the one with the lowest power. So looking at 3, 5, and 6, we want to take the 3. So that's x to the third. So our greatest common factor is 2x to the third. So when factoring out a greatest common factor, the easiest thing to describe it to is the distributive property. So essentially what we do when we factor out the greatest common factor is we do the opposite of the distributive property. So to have a visual here, I have the distributive property, and we know that the distributive property relates to when we have a number or a variable sitting on the outside of the parentheses, we distribute that to everything on the inside. And what we're essentially doing is we're taking that a and we're multiplying it to everything on the inside. Well, factoring out the GCF is the distributive property in reversed. What we're doing is we're taking a look at a polynomial and we're looking at what they have in common. So for example, here we have this a in common with this a. And what we want to do is we want to pull out that a. And then in the parentheses is what we have left over that's not in common, right? So our GCF represents what we have in common with all three terms. And in order to factor out that GCF, in order to pull that GCF out to the front, well, what do you think we do? If the distributive property tells us to multiply and we're doing the opposite of the distributive property, then going in reverse, we are dividing instead of multiplying. So what we do is we take this greatest common factor and we divide it out of each one of these terms. We're pulling it out of each term, and the way that we do that, label this algebraically here to figure out what we would be left with when we pull that out, is by dividing it out, and that's going to let us know what we have left over. And the way that we divide this out is by using the quotient rule. So just in case you've forgotten, the quotient rule states this. It says that when we are dividing like bases, that we move our base over and we subtract our exponents, always the numerator minus the denominator exponent. So that is exactly how we're going to factor out this greatest common factor. So we're dividing it out of each term, and we need to go ahead and carry out these divisions. So taking a look at our first division, 22 divided by 2 is 11. And looking at our variables, x cubed over x cubed, well, those cancel out. We have the same thing over itself, or using this quotient rule here, 3 minus 3 would give us a 0. Drop down your plus sign and continue. 36 divided by 2 is an 18. And using our quotient rule, we would have a 5 minus 3 to give us x squared. Drop down the minus sign and do 12 divided by 2, which is 6. And using the quotient rule gives us 6 minus 3, which leaves us with x cubed. This right over here, so this 2x cubed is our greatest common factor that we put out to the front. This trinomial left inside here, this is what we have left over after factoring out that greatest common factor. So both of these together here represents our simplified polynomial. So then this example is just another example of how to factor out a greatest common factor given a polynomial. So in order to begin this problem, we first need to figure out what is the greatest common factor. So again, we need to compare our numbers, compare our variables. -8, 14, and a 12. One thing that we haven't seen yet is this negative out in front, and there is something different that we have to take care of when it comes to this. And what we need to know is that if the leading term is negative, that negative must be factored out along with the other factors. We never want our leading term to be negative when it comes to factoring. So all we're going to do is we're going to tack on that negative over here to our GCF. Otherwise, we need to look at our numbers, 8, 14, and 12, and come up with the greatest common factor for all three of them. So remember, our greatest common factor cannot be bigger than our smallest number, and our smallest number is 8. And the only factors of 8 are 1 and 8, 2 and 4. Now, 8 does not go into 14 and a 12. 4 does not go into a 14, so the biggest factor we have that goes into all three of these numbers would be the 2. So far we have a -2. So then, looking at our variables, remember we need to first make sure that each term has our variable. So let's take a look at x first. So then let's take a look at our variables. And from what we hopefully remember about factoring out the greatest common factor with variables is that we want to first make sure that each of our terms has that variable. So let's double check that first. Looking at x, I do see an x, an x, and an x, so we're good there. But taking a look at y, I have a y here. I do not have a y for my middle term. I do have one for the third term. But because I do not have a y in this middle term here, y cannot be a part of our greatest common factor because it does not have it in common with the entire polynomial. So I can't involve it. But we can look at x. I do have an x in all three terms, and I want the one with the lowest power. So here I have a 3, a 2, and a 6. So I'm going to take the 2. So our greatest common factor is a -2x squared. So let's take a look and see what we're going to get when we factor that out. All right. So we know that our greatest common factor is -2x squared. So then what we're going to do next is actually go ahead and factor it out of our polynomial. So we want to bring our greatest common factor to the front, and to figure out what our polynomial is going to look like, remember we actually need to divide it out from each term. That's what we're doing when we are factoring out the greatest common factor. Remember, this is just following the reverse distributive property. So in order to actually do this division, we need to know the quotient rule. And the quotient rule says that when we divide like bases, right, we move that base over and we subtract those exponents. And remember that we can only do this with like bases. So let's take a look at our first term and see what we have going on. -8 divided by -2 gives us a +4. Looking at our x terms, we have x cubed over x to the x to the second power. So that gives us a 3 minus a 2, which is 1, so we get x to the first. And we have a y to the 7th that we can just drop down. Taking a look at our second term, a positive over a negative is negative. Otherwise, 14 over 2 is 7. And here our x squared terms are going to cancel. We have 2 minus 2, which is 0, or remember, anything over itself is equal to 1. So that essentially just means that it cancels here. Drop down the minus sign, and we have 12. Well, actually, I'm sorry, here we have a negative divided by a negative, which is a positive. We have 12 divided by 2, which is 6. We can use the quotient rule on our x terms. We have x to the 6th over x squared. So that 6 minus the 2 gives us x to the 4th. And this y to the 5th hanging out there, we did not do anything to it. It did not disappear. It is still there. So after factoring out that negative 2x squared, we are left with this as our solution.